We can use experimental methods like spectrophotometry to monitor the concentration of reactants and products to determine the rate of a reaction. Now the rate law expresses the rate of reaction as proportional to the concentration of each reactant raised to a power, and each power is the order of the reaction with respect to the reactant, and the sum of the powers is the overall order of the reaction. Now the constant of proportionality K is the rate constant, and generally this is temperature dependent, and the units reflect the overall order of the reaction. We can determine the order of a reaction with respect to each reactant by conducting different experiments where we measure the different initial reaction rates using different initial concentrations of the reactants. So for example, if we want to determine the order of a reaction with respect to reactant A, well, we'll look for the experiments where the concentration of the other reactants is constant, and now writing the rate law for experiment 4. And dividing this by the rate law for experiment 3. Then cancelling out the terms for reactant B and C because they're identical between both experiments, and then substituting for the rates and the concentrations of reactant A, where we can take the quotient to the power of x using some algebra, and that gives the following result. So therefore the exponent x is equal to 2, and the order of the reaction with respect to reactant A is 2. And if you follow the same process, by selecting from 2 experiments as we've done, you'll obtain y equals 1 and z equals 0. And a number to the power of 0 is simply 1. And therefore the order of the reaction is the sum of the exponents, which is 3. And the unit for the rate constant can be obtained by substituting the units for the rate and the concentrations. So therefore the units of the rate constant will be molar to the negative 2 by the reciprocal of second. The following experimental data was obtained for finding the rate of the following reaction. And part A asked to write the rate law, which is equal to the rate constant multiplied by the concentration of each reactant raised to the order. So using experiments 1 and 2, where the concentration of B is constant, we can find the exponent for reactant A by dividing the rate laws obtained from both experiments. So x is equal to 2. And I'll leave it for you to select 2 experiments to verify that the order of the reaction with respect to reactant B is 1. Now if half of reactant B is consumed in experiment 3, what is the remaining concentration of A? So 2 moles of A are consumed for every mole of B. And if half of reactant B is consumed, 0.01 molar of A is consumed, assuming you have the same volume of both reactants. So therefore the remaining concentration of A is obtained by subtracting this concentration from the initial concentration. And calculate the value of the rate constant. So to do that, we can use any experiment. So substituting the values from experiment 1 into the rate law. You'll obtain the following result using one significant figure.